Nowadays, we use clothes made from artificial yarn like nylon and terylene. They are durable and convenient to use. Have you experienced a terylene shirt sticking to the hair on the body? Have you heard the crackling sound a silk sari makes as it is unfolded? Let us try an experiment. Spread some tiny pieces of paper on a table. Bring a plastic ruler near them. We do not see any effect. Now, rub one end of the ruler with a paper ball and bring that end again near the papers. They are pulled towards the ruler. You could do the same experiment with a plastic comb too. Generally, if we rub a plastic ruler or comb on paper, an electric charge develops on them. It is because of the charge that the paper scraps are attracted to the comb or ruler. As this charge remains still on an object, in this case a ruler or a comb, it is called a static electric charge. Let us try another experiment where static electric charge is produced. Blow up a rubber balloon. Rub it on your clothes and hold it close to a wall. Why does it stick to the wall? When balloon is rubbed on a cloth, a static electric charge is produced in it. So, it sticks to the wall. Now, repeat this experiment, rubbing the balloon on different types of cloth and on paper. Find out if it sticks to an iron rod. No, it will not stick to the iron rod. Iron is a good conductor of electric charges because it is a metal, and so it cannot develop a static charge on it. Do you know why this property of an object is known as static electricity? Let us look at the history behind it. About 2,500 years ago, Thales, the Greek scientist, had used a resin called amber and a woolen cloth to conduct an experiment related to static electricity. In Greek, amber is called electron. That is why Thales gave the name electricity to this property. Later, in the 16th century, the English scientist William Gilbert conducted many experiments with diamond, emerald, and other gemstones. However, only certain pairs of substances give rise to electric charge. Besides, this electric charge is very weak and lasts only for a short time. There are two types of static electric charges: positive electric charge and negative electric charge. When a glass rod is rubbed on silk cloth, the rod develops a positive charge. A positive charge is denoted by a plus sign. When an ebonite rod is rubbed on woolen cloth, a negative charge develops on the rod. A negative charge is denoted by a minus sign. Let us try another experiment to study the properties of static electric charge. Take a straw we use for sipping cold drinks. Cut it into two equal parts. Push a pin through the center of one piece and stick it to the top of a wooden table as shown. Make sure the straw can turn freely around the pin. Now, rub the other piece on a paper. Bring that piece near the one fixed on the table. The two ends are attracted to each other. This shows that an object with charge attracts an object without any charge. Now, rub one end of both the tubes on paper and bring them near each other. The two ends move away from each other. What is the reason for this? As the material of the tubes was rubbed on the same substance, that is paper, Electric charge of the same kind was developed on each. This shows that similar charges repel each other. The experiment can be done by rubbing ebonite rod on wool and a glass rod on silk. Try this. Hang from a stand an ebonite rod charged on wool. Bring another ebonite rod charged in the same way near it. They will repel each other. Now bring a glass rod charged on silk near it. The two rods will attract each other. From this, we come to know that like charges, for example, the two negative charges on ebonite repel each other, and that two unlike charges, for example, the positive charge on the glass rod and the negative charge on the ebonite, attract each other. Now let us see how transfer and induction of electric charge takes place. You know how tug-of-war is played. There are an equal number of players on either side. The team which has stronger players pulls over the weaker team. What will happen if all the players had equal strength? Both the teams will be equally strong and neither side will win. Now what will happen if a player of one team crosses over to the other side? The first team is one player short. The second has an extra player. The latter team becomes stronger. The teams are not balanced anymore. This is how minute particles go from one substance to another and electric charge is created. Why does rubbing one substance on another create charge? Every substance is made of matter. You have learnt that the smallest particle of matter is called atom. Every atom contains smaller particles with either positive or negative charge. As the number of positively and negatively charged particles in an atom is equal, they neutralize each other. As a result, the atom has no charge. Every substance is different because of the structure and number of atoms. Even so, ordinarily, it has no electric charge. Electric charge is created only when specific substances are rubbed together. On rubbing, some negative particles are transferred from one substance to the other and the latter develops a negative charge. Example, when silk rubbed on glass. The substance that is glass from which particles are removed loses negative charge. Hence, it develops a positive charge. The minute particles with a negative charge are called electrons. Let us now study about electrical induction. Now, what happens if a body with no charge is brought near another body with positive charge? As we just read, in the uncharged body, the number of positive charges and negative charges is equal. The negative particles in it get attracted towards the positively charged body while the positive particles are repelled. What is the effect of this? The negative particles collect at that end of the body which is nearest to the positively charged body, while the positive particles collect at the opposite end. Thus, an opposite charge develops on the end nearest the charged body and a like charge at the farthest end. This action of electric charges which takes place when two bodies are brought close together is called electrical induction. Now, what happens if the charged body is removed? The charges at the two ends of the other body mix together again and no charge will remain on it. It means that an induced charge exists only so long as the charged body is placed nearby. We can also see that the attraction between a charged and an uncharged body is due to the induced opposite charge. Let us study about the electroscope, a simple device used to identify electric charge. In the electroscope, a metal disc or ball is attached to one end of a copper or aluminium rod. Two thin metal leaves are attached to the other end. This rod is fitted in a one-holed cork stopper, and the stopper is fitted on a conical flask in such a way that the metal leaves will be inside the flask and the disc outside. Cork is a bad conductor. Sometimes, to make the electroscope more sensitive, gold leaves are attached to the end inside the flask. If a body with no charge is made to touch the disc of the electroscope, the leaves at the other end remain closed. But if a positively or negatively charged body is brought in contact with the disc, then like charges develop on the leaves and they repel each other and fly apart. The moving apart of the leaves of the electroscope is the test for finding out if the body is charged. Let us come to the last part of the chapter, the lightning conductor. When lightning strikes close to the ground, there is a danger of fire or loss of life. Tall buildings, particularly, are at greater risk. To prevent any damage due to lightning, a lightning conductor is fitted at the top of a building. A lightning conductor has a pointed shape and is made of copper. A thick strip of copper is attached to it. The other end of this strip is buried directly in the ground. When lightning occurs, it is attracted to the pointed lightning conductor and from there flows directly into the ground. Thus, any damage to the building due to lightning is prevented.